All right, let's take a look at our second example. If y varies directly as x, again, here's your key information telling you that it's direct variation. And we know that x equals 8 when y equals 5. Now we want to find x when y equals 8. So very similar type of situation. The only difference here is in our final answer, we're going to be looking for x instead of y. So let's start off by using our direct variation equation, y equals kx. We're going to input our first x and y values. So we're going to input 8 and 5 in for x and y. And we're going to solve for k by dividing by 8. You can just leave that a fraction. That's 5/8. Again, now that we know what k is, we can rewrite that equation. Instead of y equals kx, we can now write this as y equals 5/8 x. We use whatever information is left, so we know that y equals 8. So we're going to substitute 8 in for y. And now we're going to be solving for x. So now we need to do a little bit more as far as solving the equation. We need to get rid of that coefficient 5/8. So if you remember, probably the easiest way to do that is by multiplying by the reciprocal of 5/8. So multiplying by 8/5 on both sides. So that coefficient cancels out. And we're going to be left with 64/5. If you wanted to go to decimal, it's going to be 12.8. And with these, perfectly fine to leave it as a fraction, or you can go into a decimal. As always, if we have a non-terminating decimal, we want to leave that as a fraction.